Hello and welcome back. Thought I'd talk a little bit more today. Again, this is COM 3928 Research Methods. Thought I could talk a little bit more today about the current assignment, which is normality, or normal distribution of data. Once again, conceptually, as we talk about our data, we've done our survey, we've collected a lot of answers to a lot of questions. I think on our assignment and our test data, the variable you'll be using is multi-sum. It's actually a summary of an involvement scale that I measured. So the question might be, how much do you enjoy running on Sundays? Between a 1 and 5 scale, it would be not very much at all or very exceptionally a lot. So there'd be a spread between the 1 and 5 on the scale. That's what the measurement would be. So when we think about that, we're always in statistical research trying to do tests which give us statistical significance. That's what we're always looking for, and that's what we want to talk about. That's what we have to be valid in our research. The point is, that's called parametric testing. And many times in research, and I learned this the hard way from getting a lot of reviews back from the research I try to get published with journals, is someone would say, do you have normal distribution of your data? I wasn't sure. And one of the things, and a big mistake that happens in research often, is that we don't test our data results for normality, for normal distribution. If we don't have normal distribution of our data, we're not supposed to be doing parametric testing, which gives us what would be statistical significance. So the idea is we better know we have normally distributed data or close to that. So for starters, let's think conceptually. What is normally distributed data? We've got our data line. Of course, we've got a mean score in the middle, and you've probably seen it in other areas of study. Normal distribution is when we lay all the data dots, all the answers to those questions from all our respondents in the survey. When we lay all the data points out, we should have data that runs up, has a camel hump in the middle, right over the mean score, and then goes out. Of course, the far ends are the tails. And if we go way, way outside the tails, those are outliers. But the bottom line is normal distribution is this nice camel hump curve right over the mean score, and then equal data distributing down both sides and away from the mean score. Okay? We have statistical tests that show us how to do that. And in this assignment, you'll look at the multi-sum variable. You'll be checking for skew and kurtosis. Kurtosis, again, skew is the lengthening, the spread of the data. Kurtosis is the hump of the data, high and low, the level and hump of the data. So again, think about it conceptually, and then there's also a couple of other more involved, sophisticated normality tests that we'll also run in this assignment. But the big idea of it all is when we're going to be testing with variables, we should know if we have normal distribution. So run the different tests I've asked you to do. Also think about the histogram, where you can just take a look at a bar graph, and that gives you a really nice visual way to eyeball the data and try to decide what's really there. So please put that together, walk through the steps of the assignment, look at the different ways the data is distributed, and then tell me what you find out with the variable I gave you. Is it normally distributed? Is it not? And if not, what happened? What can you tell me about the audience based on the way the data fell for that one variable? Thank you.